Welcome back to Need Those. Before starting the video, if you are new to this channel, please subscribe my channel and switch on the bell icon. So let's start our video. In today's video, we are going to discuss about units and dimensions. First, accuracy. Accuracy is a measure of closeness of measured value to the true value. It is not a term just to read and leave. We should understand it properly. In daily life, we use it many times. Accuracy, accuracy. Even in cricket, while we are bowling, we find accuracy for the stumps, accuracy for the sixes, and while in archers, we find accuracy for the 10 points. In in daily life, we have many examples for accuracy, and we use it regularly. But what does it mean accuracy in instruments in physics? In accuracy in instruments is nothing but we can measure a many values by an instrument, but we will have only a mean value to be measured by it. We may measure errors, we may measure correct values, but while measuring errors, you will find a value that is closest to the perfect value. The closest value to the perfect value is known as accuracy. That's nothing but accuracy. Next, coming to precision. Precision of an instrument gives minimum value that can be measured by it. Minimum or limited value is most important terms in this definition. This definition gives a meaning of while measuring with an instrument by an, for example, by electronic physical balance, we can measure 10 kg, 20 kg, 10 kg, but the least is we can measure 1 gram also. That's the precision. The minimum or limited value that can be measured by an instrument is precision. Let's start another topic, dimensional formula. In dimensional formula, let's go for definition. It's a formula showing powers to which the fundamental quantities must be raised to represent a physical quantity is called as dimensional formula. In dimensional formula, mostly it is not related to the definition. It's related to the understanding levels of your brain. See, in dimensional formula, we will write a formula showing powers to which the fundamental quantities must be raised. We all know fundamental quantities we have read in physical world must be raised to represent a physical quantity is called as dimensional formula. We have many examples in daily life. So what are the fundamental quantities that we use in dimensional formula are mass. We represent it by capital M. Next, coming to length, we represent it by capital L. Temperature, we represent it by this like temperature gradient symbol or capital K. Next, time, we represent it by T. Electric current, we represent it by capital I or ampere. So friends, we have seen dimensional formula and its definition, its meaning, and we have seen some fundamental quantities that are regularly used. So let's solve a question for our better understanding. They have asked a question like write dimensional formula for universal gas constant. You should underline the universal gas constant in exam or in your daily life in daily practice because we have two terms, universal gas constant and gas constant. Both are different, both have different dimensional formula. So it's better for you to make a note, underline in question paper also. So let's start with solution. We are most familiar with the ideal gas equation, PV equals to nRT. You all know that. From this we can find universal gas constant. First, let me explain the terms used in the ideal gas equation. P refers pressure, V refers volume, N refers number of moles, R refers universal gas constant, T refers temperature. Let's solve this question further. R equals to PV by NT. We all know that we send both number of moles term N and T to this side. Pressure equals to force by area. This also we are most familiar. Then V and NT remain same. We all know the dimensional formula of force. We can derive it in exam, but it's most important for you to remember some dimensional formulas like force and energy. So let's solve dimensional formula for force. We know force equals to ma. M means just dimensional formula is m. Area means rate of change of velocity to the time, means v by t. Here m remains same. V means again we write distance by time, distance by time to the time again. C finally it becomes m into d by t square, d by t square. If we write it as dimensional formula, we get m power 1. We can represent it or not, but 1 remains. D means length. D means distance. That dimensional formula is length. Here t power 2 to the base. If we come into the powers, it becomes T power minus 2. If we write dimensional formula for the temperature, we may write it capital T power minus 2. Let's write it as theta. This is time to the base T. Here it becomes T power minus 2. This is the dimensional formula for force. M power 1, L power 1, T power minus 2. Here that represents the dimensional formula M power 1, L power 1, T power minus 2. Base is area, means L square. Volume means L cube. Number of moles means we represent it in mole. Capital T refers temperature, that we write by theta. Here T refers time. While solving the solve, we get L square get cancelled here. L remains same. One L will be remain, and there is another L here. We get L square. Only one M term, M L square. Here one T power minus 2. Mole becomes minus 1, theta becomes minus 1. Finally, the dimensional formula for universal gas constant is ml square t power minus 2 mole inverse theta inverse. This is the dimensional formula for universal gas constant that we derive by using ideal gas equation PV equals to nRT. This is the explanation for this question. So friends, we have solved an example related to dimensional formula, and you should practice more and more questions related to dimensional formula, because there may be one or two questions will be asked in final NEET exam. So should be clear in concept and problem solving things. If you have any doubts, please post them in comment section. I will reply to you. And this slide represents electric charge and pole strength Q and M, represented as I and T, I and L. This is the solution for your question mark while solving dimensional formula for some terms. In that some terms, these terms will be appearing Q and M. While solving that, we have many. We can write Q equals to I by T. Many I Q equals to. We have many formulas, but writing I and T saves your time. If you write I and T, that both are same fundamental quantities. I is the current, T is the time. If you write this both of them, the both are already in fundamental terms, then the time will be saved. While coming to pole strength M, it represents I and L. I is the electric current, L is the length. Both are fundamental quantities. It saves your time, right? So use the terms I and T instead of electric charge. Use the terms I and L instead of pole strength. This saves your time. So friends, let's solve another question, another numerical related to dimensional formula, that is most important term we use, coefficient of viscosity. So let me explain the question for you. Write dimensional formula for coefficient of viscosity. See the term coefficient of viscosity or viscosity. Both may be different. See, while coming to the equation, you should be thorough with all the formulas, all the simple things. See, we can write coefficient of viscosity formula as C. Viscosity force equals to Na dV by dx. This becomes more complicated when you use for deriving the dimensional formula for coefficient of viscosity. It becomes easy for you by writing the 6 by nRV. N is the coefficient of viscosity, R is the radius, V is the velocity. This becomes more easier for you for writing the coefficient of viscosity. Remember this for making dimensional formula for coefficient of viscosity. For C, we need dimensional formula of viscosity, right? N equals to F by 6 by RV. See, both 6 by R numericals. They do not have any dimensional formula. We already know that force have dimensional formula m power m sorry m plus 1 t power minus 2, typing mistake, ml t power minus 2. Here temperature does not be, typing mistake, sorry. Force equals to ml t power minus 2. It is the force dimensional formula. R refers to length, V refers to L t power minus 1. On solving this L and this L gets cancelled. M t power minus 2. Here one more t power minus 1 gets cancelled. V minus 1 gets remained. Finally, we get m L power minus 1. Here L. This L becomes to the top and becomes L power minus 1. And t power minus 1 is remained. That becomes m L power minus 1 t power minus 1. So friends, I have made a typing mistake here. This is the final dimensional formula for coefficient of viscosity. It becomes more complicated here, Na dV by dx, doing differentiation and everything. But it becomes easier and saves our time by using this formula. Viscosity force equals to 6 pi coefficient of viscosity eta RV. This is the solution. So friends, we have seen two examples related to dimensional formula, and now let's go for applications. Before moving to applications, I should tell to you a shortcut or a takada. Here dimensional formula represent, we use dimensional formula in final exam, like if you are finding trouble to solve the question and the time is less, you can use this dimension formula concept for finding the perfect option. Let me explain how. See that if they ask you to find something like velocity and the problem is too long, and at least one or two questions will be like this, that units will be different. They may give numericals also different or the same. But if you find the units, they ask velocity, the unit should be length by time. Based on the trick, we can find the correct option without solving. At least one or two questions will be in final exam like this. So let's coming to the slide, units and dimensions, applications. The first application of units and dimensions, not your first application of dimensional formula is principles of homogeneity. This is the first application. For your better understanding, let's go with an examples of example represents displacement y equals to at by x square plus bt cube by y. Then find dimensional formula of a and b. Here they give an equation, displacement y equals to an equation at by x square plus bt cube by y. Here a is a positive constant, t is the time, x square is the x is the length, b is the again a constant, t is the time, y is the again displacement or distance or length term simply. They asked us to find to the dimensional formula of A and dimensional formula of B. To solve this, we use the principle of homogeneity. How? The dimensional formula of at by x square and bt cube by y is equal to y. Based on this, that's homogeneity. Dimensional formula of this both will be equals to this. Using that, we derive dimensional formula of A and B separately. See, we separated it for these two. Y equals to at by x square. This is one. For this, y equals to bt cube by y. This is separate for these two. And y equals to at by x square. Here we need to find dimensional formula of A. So if we remind it here, we send x square and t this side, we get yx square by t from here to here by sending this term and this term to this side. Here y represents L term, x square also represents length term. So finally it becomes L cube. and t represents time. Finally, L cube t power minus 1. The same thing we should do in B also. B, we send y here and t cube here. We get finally y square by t cube for B. L square, y square represents length term, that's because that's why L square. T cube represents time, that's t cube. Finally it becomes L square t power minus 3. And here the solve the if you find here, if you substitute L cube t power minus 1 here, and if you find dimensional formula, finally it becomes dimensional formula of length here and here both, because here it represents length. That's the meaning of principle of homogeneity. This is the example. Friends, let's go for another application of dimensional formula, that's conversion of quantities from one system to another system. This is the second application of dimensional formula. Here we use a formula known as N1U1 equals to N2U2. This is the most used example in this application. Here N1 represents a quantity, U1 represents unit, N2 represents quantity, U2 represents unit. Unit 1 is the unit in one system, U2 is the unit in another system, N1 is the number or numerical in one system, N2 is the numerical or number in another system. Here for this for your exam, for your understanding, I have taken like 2 kg. N1 is 2 kg is U1 is kg. 2 kg is equals to 2000 grams. N2 is 2000, U2 is g. This is explanation for this. So friends, let's solve a numerical related to the second application, N1 equals to N2. Here the question for you. In a new system, unit of mass is 10 kg. The unit of length is 2 meters and the unit of time is 0.1 second. The energy of your body is 250 joule. Express this in new units. This is the term. Here unit of mass is 10 kg in one system and its unit of length is 2 meters in one system. Unit of time is 0.1 second in this is in first system, this three quantities. And the energy is 250 joules. We should represent this in new units, means we should represent this whole in another system. We all know that energy dimensional formula, that we should remember it, equals to ml square t power minus 2. Here we should write N1 equals to N2U2. Here the number 250 represent N1 and the units from these terms are ml square t power minus 2, kg meter square second in second minus 2. We write these units based on this dimensional formula, and this is the most important, that we cannot derive dimensional formula all time from units, and we cannot derive units all time from dimensional formula. That's the main thing you should remember. Both will be different for sometimes, for some terms and at some times. See, you find some quantities which have dimensional formula but they have no units, like refractive refractive index, and some examples are there. That's different scenario. Here 250 is one term, kg meter square s power minus 2. Writing N2 in another system, here they have given this is 10 kg 2 meter square 0.1 second or minus 2. Based on this, here 250 remains same, N2 10 kg 2 per minus 1, same thing. If you solve this, here 10 kg 10 kg, here 2 square becomes 4 meter square, 0.1 means 10 power minus 1. Minus 1 to the power minus 2 becomes minus 1 into minus 2 becomes 2, means it becomes 100, means 10 square s power minus 2. Here this side is 250. If you solve this, 1 0 gets cancelled. Again here 10 square means again we get here 4 with 25, we make it cancel with 4. Here 1 remains, equals to 4 into 4, that's 16, and the terms kg meter square s power minus 2 and N2 remains, here N2. Or and 2, if we send this 16 to this side, it becomes 1 by 16. That's the final answer, 1 by 16 in new units. This is the solution for this. So friends, let's solve another numerical related to conversion of units from one system to another system. This is the numerical for you. In a new system of units, unit of length is 2 meters. Mass is 10 kg. Time is 0.1 second. Unit of energy in that system is, here they are asking that they have given unit of energy means energy equals to 1 joule. And they have given length is represented by 2 meters, mass is represented by 10 kg, and time is represented by 0.1 second. By substituting here, N1 is the term and value of energy in one system, kg meter square by s square. We should find this N1. This is the new system. Here unit of energy is 1. We represented by 10 kg, 4 meter square for the length, 0. Sorry, it's there is no 1 0. 0.01 second square for the time. Finally, it becomes here 10 square, 10 power minus 2. It becomes 10 square while going to numerator. From this 2, if it goes to numerator, it becomes 10 power 10 square. Finally, it becomes 10 cube in the numerator. That means it is equals to 4 into 10 cube in the numerator, and you should write here the units kg meter square by s square. It becomes here. As they ask new system of units, n1 equals to 4000. We get here all the kg terms, meter square, s square becomes cancelled. Finally, n1 equals to 4000 remains. So in 1 unit, the energy is represented by 4000 joules. This is the final answer, and this is the explanation for this question. So friends, till now we have seen two applications of dimensional formula. We are going to see another dimension from another application of dimensional formula, that's to derive the equations. We are going to derive equation that is unknown for us by using the terms that are related from the question. For example, force depends on density rho, area capital A, and velocity c. Then they ask you to derive the formula for force. If you write solution for this, see, let us assume the powers to be x, y, z. The force is directly proportional to O power x, means density to the power x. Force is directly proportional to capital A to the power y, means y to the power of A, so to the power of c, means velocity. These three terms, if we add and finally we get this, F is directly proportional to O power x, A power y, C power z. If we substitute the dimensional formulas, we know first dimensional formula is m L power 1 T power minus 2. We do not know the x, so we should write dimensional formula for density is m power 1 L power minus 3 to the power x. So it becomes m power x L power minus 3x. Same for area, L to the power of y. For c means velocity, L power 1 T power minus 1. If we multiply it with z, it becomes L power z T power minus z. By solving this means we should take here m, only one m term is present on right side and only one m term is present on left side. See, means this term we should equal to this term. So finally we get x equals to 1 here, m power 1. So we get x equals to 1. We have get solution of x. Then let's go to solve with y. See, let's equate L terms. Here L power 1 on left side, L power minus 3x 2y z, means minus 3x plus 2y 2y plus z is equals to 1. This is the equation for finding y. Here L power minus 3x plus 2y plus z, that is equals to 1. While writing equation for t, on this right side only minus z for the t. Minus z is equals to minus
2. Minus minus gets cancelled and we get z equals to 2. Substitute x and z in this equation and find y. This is the solution for this question. Find the y and comment the y value in comment it. Friends, we have discussed dimension formula clearly. If we have any doubts, post it in comment section about dimension formula. I will reply to you. And let's go into another topic, that's errors. Errors are common in physics. Errors. We have two types of errors. The first one is systemic errors. In systemic errors is always unidirectional. It's not bidirectional or reverse. It's only single direction, unidirectional. In systematic errors, like instrumental errors, we have one weight balance represents 10 kg as 9 kg in another. That's our instrumental errors. Environmental errors. At some places the pressure is high, at some places the temperature is high. This environmental errors also affect the final measurement. Personal errors, that's related to I, that is related to us, maybe eye, hand, anything. If we are measuring a scale, if you are measuring a scale, means scale nothing but if you are measuring something with a scale, if you see there, if you observe it from left side, you will find different reading. If you observe it exactly from top, you find one reading. If you observe it from right side tilted, you will find another reading. Those are our personal errors. And next error is improper experiment techniques. This is mostly known to you, improper experiment techniques, because before if you do anything by taking one, if you take another, it becomes improper. This is the systemic error. Next, coming to second type of errors, that is random errors. In random errors, errors are irregular. They are irregular in nature. The cause is not known. For the random errors, the cause is not known and they are irregular. Here, this is two terms that are most important related to random errors. Here, you should remember this. You should remember this statement as like fixed. It should be fixed in your mind. This is a direct statement. Zero error is an example to systemic errors. This is the line they have asked many times in NEET exam. So remember this must. Friends, let's again coming to units and dimensions. Another subtopic, measurement. In measurement, we should see in addition and subtraction, the absolute errors should be added. This is the statement you should remember. You will remember it by doing more examples. See, for example, there is a question below that if x equals to y plus or minus 2 and y equals to 10 plus or minus 1, then find x plus y and x minus y. For solving x plus y, simply add the terms that are given. Means 5 plus 10, that's 15. Sorry, it's mistake. 15. 15 plus or minus 3. Simply add the terms on both sides. On finding x minus y, simply subtract the bigger small term from the bigger term and add this. This is the most important in finding. See, you will all commonly do the major mistake here, x minus y. You will simply subtract on both sides. See, if you do 10 plus or minus 1, if you subtract it from 5 plus or minus 2, many, if they find x minus y, they will subtract it, means they will find 5 here plus or minus, they will keep as it is, and again they will write it here minus 1. This is absolutely a blunder mistake. Simply add the terms on this side. If it is x minus y, just subtract on one side, that is 10 minus 5 means 5, and add on other words, 2 plus 1 means 3. This is the term x minus y. This is the solution for this. Now I think you are clear about finding x plus y and x minus y. Coming to second subtopic of measurement, we find here in multiplication and division, relative errors or percentage errors are added. This is the second application. Same, it is no need to remember it. By solving huge large number of numericals, you will remember it constantly. In the question, they have given a equals to 5 plus or minus 0.1. Here they have gone to decimal. B equals to 20 plus or minus 0.4. Then ask then they ask you to find a cross b and b by a. Means we should multiply a and b, and we should divide b by b to the 8. See, finding they have given a. First, convert this 0.1 into percentage. Means 0.1. We should finding that, let's take 0.1 is equals to something x by 100 into 5. Yeah, we should take 5. Then you will get it. What's it? 5 we will get it with cancel with 220. 20 into 0.1 we will get 2. Means x equals to 2%. This is how we get 20%, 2%, sorry, 2% from 0.1. You should find it from like this, just using the percentage technique. Same, you should find it for B also. 0.4 is equals to something y by 100 into 20. 20 gets cancelled here by 5. Again 0.4 into 5, it gets 2. Again 2 percentage for 0.4. You may feel that here is it's 2% and here is 2%. But here the two terms 0.1 or 0.4 are different. Then why we get both same? Because of here the numerical is 5 and here the numerical is 20. That's the reason we get here same. It's based on this numerical whether we may get it same or different. Here finally multiplying a and b. See, you should multiply these two terms. Relative error or percentage error mean are added from this. They should be added. The percentage errors should be added. Means 2 plus 2%, that's 4%, and multiplying this to 20 into 5, that's 100. Then finding b by a. Here b is 20 plus or minus 0.5. In dividing this, divide 20 plus or minus 0.4. That's not we should, yeah, we should find direct absolute error 0.4 by 5 plus or minus 0.1. 5 divides it by 4. Here we get divided by 4. Means we get 4 plus or minus 4 percentile. Means 4 plus or minus 4 percentage. This. Making this into the percentage error, making into absolute error means 4%. Already we know that. We don't know this term. They have given 4% of 4 means 16 by 100, that means 0.16. This is the b by a. This is the final solution for this. Now let's move to a note point that is most important in measurements. That's if p is equals to a power x, b power y, c power minus z, then percentage error in p is given by delta p by b into 100 is equals to x, that is by power x into delta a by a into 100 plus y delta b by b into 100 plus min. Here whatever the term plus or minus is used to the powers, you should take only the positive. Z delta c by c into 100, it's plus taken here, whatever it may be here. This is the blind. We should the term we should remember it. We should remember it here. We should remember this formula. Since this is an important question or important model, you should remember. They have given question as if R1 equals to 100 plus or minus 2 ohms, R2 equals to 200 plus or minus 3 ohms, then find R effective in parallel combination. We should find effective resistance in parallel combination. We know in parallel combination the two resistors are connected to the different ends. Sorry, to the same ends. Here will be one resistor and again it will be another resistor. These two ends This is one end and this is another end. These two are connected like this. This is parallel combination. If it is series combination, it will be like this. This is the series combination and this is the parallel combination. Here for the finding effective resistance in parallel combination, we will find a formula known as 1 by R equals to 1 by R1 plus 1 by R2. In series combination, R effective equals to R1 plus R2. This is the difference in the formula. As the it has asked in parallel combination, so formula becomes 1 by R equals to 1 by R1 plus 1 by R2. Here minus 1 by R square, the effective resistance, we get substituted by delta R by R. Minus 1 R1 square delta R1 minus 1 R2 square to the delta R2, or we can use the formula. If we solve this, we may get like this: R equals to R1 R2 by R1 plus R2. Delta by R is the total effective resistance. If we solve this, we'll get 200 by 3 whole square equals to delta R1, means error in the first resistance 2. The first resistance means 100 square. Error in the second resistor 3. That's in 200. We solve this for the effective resistance by using this R1 R2 by R1 plus R2. This one we should use only these two terms. 20,000 by 300. You will get 200 by 3. Finally, if you solve this, you will find error in the R effective. This is the solution for. Friends, here comes the most important topic of this chapter, units and dimensions. That's significant and figures. Significant figures. This is the most important. At least you may find one or two questions from this. In final exam, they may ask one or two questions from this topic. The two topics may be from, one is from dimensional formula or significant figures. If the paper is so easy, they may ask two questions. One is from dimensional formula or accuracy and precision, or another again it from significant figures. See, let's going to understand this. There are many rules for the significant figures, but remembering the rules is a different task, is a difficult task for us. But in a different way, let us remember it through examples. See, here 6 comma 482, there are four terms. Again, coming to here 648.2, 64.82, 6.482 have four significant digits. This represents this first point represents the rule. All the non-zero terms in a numerical are considered as significant figures. This is the rule for this first point. We should simply count all of them, whether they have decimal or not. All are non-digits, so we should simply count them. These all four numbers have completely four significant digits. Coming to second one, 206 206,008, 206.008, 2.06008 have significant figures. Here, zero digit is there, but it is between two non-zero numbers. First zero is between 2 and 6. Another two zeros are between 6 and 8. So simply we should count this also. This all three have six significant digits. Next, coming to these two are exceptional cases. That's why I have written it. If the number is less than 1, all zeros right to the decimal point, but to left of first non-zero digit are not significant. This means here we find decimal point. This is the non-zero digit 6. These three zeros between decimal point and non-zero digit. These three zeros are not significant if the number is less than 1. Only 6, 0, 8 are considered as significant digits. That's why this one has three significant figures. Next, coming to the exception for this, if number is greater than 1, all zeros right to decimal point are significant. Here, this number is less than 1. Absolutely, this is 60. 60.00 have four significant figures. This is greater than 1. And we should count all non-zeros. All non-zeros and all the zeros to the right of this decimal point means 1, 2, 3, 4. Finally, we have four significant figures here. Coming to this, here using this is less than 1. From this, These two are non-significant. We only these four are significant. So we have four significant figures. Next, coming to the another rule, zeros to right of last non-zero digit without decimal point are not significant. Here decimal is there. This is non-zero. The zeros after the decimal point after non-zero digit are significant. But exception to this is this. 4060 have only three significant because we are not including this zero. We are not including this zero because there is no decimal point to include. Again here also 406000. We are not including these three zeros because there is no decimal point. That's why this have only three significant figures 406. While coming to a standard and exceptional case, that is 4.500 into 4.500 into 10 cube. Means millimeter. This is the standard representation for 4. This is standard representation for 4.5 kilometers. I think you may find it have only four significant digits. We do not include this 10 cube into finding significant digits. Only these terms 4.500. We include only these for significant figures. This all make a note or take a screenshot in your phone or laptop and do it as examples. Solve more numericals. You will be clear in significant figures and easily you can secure 4 marks in final exam. Next, coming to rounding of uncertain digits. Units and rounding of uncertain digits. Preceding digit is raised by 1 if immediate insignificant digit to be dropped is more than is to drop is more than 5. Preceding digit is left unchanged if immediate insignificant digit to be dropped is less than 5. See, you find it rounding off in many equations. If it is a large value, we use rounding off for making it simple. If in the numerical, see here if you have this, preceding digit is raised by 1 if immediate insignificant digit drop is more than 5. See, this is raised. It's a different example, but I am explaining to you. It changes because here it is. If you think these two terms are not there, 6.72. Here is 2 and it's here is 7. 2 is less than 5. That's why we drop just 2, but we do not increase it. If it is here 8, we will increase it. As it is greater than 5, we will increase this. It becomes 6.8. That's the two examples for these 2 points. And if this is the separate case as 5 include. If preceding digit is even, means here preceding digit is even, then no change in insignificant digit and 5 is dropped. Here this is even number, we do not increase anything here. Simply we drop 5 and 8. That's it. Here it becomes 6.72. If preceding digit is odd, then it is to be raised by 1. It is 6.7158. 5 is preceding digit is 1, so we increase it by 1. It becomes 2, 6.72. Here, friends, let's see another topic that's most important. That's vernier calipers. Vernier calipers. In vernier calipers, we should remember these two formulas: least count and reading. Least count equals to 1 main scale division by number of vernier scale divisions. That is 1 main scale division minus 1 vernier scale division. We should remember its standard for vernier calipers, that's least count is 0.1 millimeter. For better understanding, let's see an example. An vernier calipers has 0.1 millimeter marks on the main scale. Its 20 equal divisions on the vernier scale match with 16 main scale divisions. Find its least count. Here we go for solution. They have given 1 unit on the main scale division is 1 millimeter. I think that is given. And they have given 20 equal divisions on vernier scale match with 16 main scale divisions. 16 main scale divisions each with 1 millimeter. If you multiply, we get 16 millimeter. Means 60 divisions on vernier scale match with 16 millimeter on main scale. Then we should find it for one division. How much? That's 16. 16 by 20. That's 0.8 millimeter. We got one vernier scale division. If you find least count, we should use this formula: 1 main scale division minus on vernier scale division. That's 0.8 millimeter. You should look after here the units millimeter, millimeter. So we simply divide, subtract it 0.2 millimeter. Here comes another formula. Reading equals to main scale reading plus vernier coincidence into least count. Here it represents when two jars. This is the reading. Means simply they will give a figure main scale and vernier coincidence and least count. We should multiply both and add to main scale reading. You will get the reading of the vernier calipers. Another important thing is zero error and zero correction in vernier calipers. When two jars are in contact, the zero of main scale and zero of vernier scale should be coincide. Otherwise, the vernier scale calipers is said to having zero error. Here simply to find zero error is equals to vernier coincidence into least count. This is the vernier scale. This simple small one is the vernier scale and this big one is the main scale. Here another important point is zero correction is the negative of zero error. Both have same numerical, only the sign changes. That's about vernier scale. Now coming to another important one, screw gauge. In screw gauge, we should remember this two along with reading formula. Pitch of the screw is equal to distance advanced on pitch scale by number of rotations or revolutions. That's simply distance advanced per one revolution. Another formula for least count is pitch of screw by number of head scale divisions. Let's understand it by one more numerical. The head scale of a screw gauge consists 100 divisions. 100 divisions. The distance advanced for 0 rotations is, sorry, for run for 10 rotation for 10 rotations. Sorry, typing mistake. For 10 rotations is 10 millimeter. Then find pitch and least count. We know pitch equals to distance advanced on pitch square by number of rotations or revolution. It is advanced by the 10 millimeter for 10 revolutions. It's a printing mistake, sorry, typing mistake. 10 by 10 means 1 millimeter. We got pitch. Then finding least count. Least count equals to pitch of screw by number of head scale divisions. We found already pitch, that's 1 millimeter. Substitute it here. 1 millimeter by number of head scale divisions here. 100 means 0.001 millimeter. This is the solution. Finally, coming to units and dimensions. Here reading in the screw gauge is PSR means pitch scale reading plus HC means head coincidence with least count. Here also zero error or zero correction occurs in screw gauge. When two stones are in contact, then the head scale 0 should be in coincide with head scale line. Otherwise, the screw gauge is said to be having zero error. Here also the same thing. Zero correction will be the negative of zero error. Here for remembrance, if 0 is below than error, if below means if this is standard line, here the 0 should be. But if it has any error, if the 0 is below this line, standard line, then we should take the error to be positive. This is a thumbnail, we should remember it. And if the 0 is above the standard line, then the error will be negative, and here the 0 correction will be negative and the 0 correction will be positive here. That's the main thing. Finally, this is up to units. This is units and dimensions given by me. Thank you for watching. Please like, comment and subscribe. Thank you friends. Bye bye.